Wanted to make a quick help video for those of you who are still struggling a little bit with electron configuration. So first thing that you should know about our periodic table, besides our orbitals, so my yellow is our s orbital, purple is our d orbital, pink is our p orbital, and down here the green is the f orbital. N stands for our energy level, and this is the first thing that we write when we write a code for electron configuration. So for electron configuration, we always have N, some letter, and some superscript. N is our energy level. The letter indicates what subshell we're in, so whether it's S, P, D, or F. And number is how many spots in it is into that subshell, or our number of electrons. So I'm going to go ahead and go through this periodic table really quick with you. The first thing that you should know is that it's organized by increasing atomic number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We read our periodic table like a book, so we read it from left to right, and we kind of follow it one line at a time. When we get to level 4, this is the 4s orbital. After 4s, so after number 20, we're now in the d orbital. So 21 through 30 is in the d orbital. N-1 for the d orbital means that the energy level is one level lower than everything else in that row. So this level is not 4d, instead it is 3d. So this is 3d. After we get out of the d orbital, we bounce back to our higher energy level, which is why we wrote our n values over here. So this is our 4p orbital. This would be our 5s, our 4d, back to our 5p. When we get down to 6, notice that, and I'm going to zoom in just a little bit so that we can really see this well. All right. Notice with 6s, we have 58, 56, and then 71. We have a huge jump here. This jump is actually because 4f actually belongs after barium. So it'd be 6s, then we bounce down to 4f. See how we have 57, 58, and we go all the way through to 70. So it'd go 6s2, 4f, and f fits 14. After we've gone through the f orbital, we're at number 70. We need to account for number 71. So after we go through the f orbital, we bounce back to the same level we were in, and we go to the d orbital. So it'd go 6s2, 4f14, then 5d10. Then over here, we'd be back at level 6, 6p6. Looking at level 7, it'd be 7s2. After radium, we'd bounce down, 5f14. After number 102, NO, we bounce back up to the last D level, 6D. And then lastly, 7F. I'm going to go ahead and do a practice electron configuration really quick just to show you. I'm going to go ahead and actually do SM. So SM is right here. And let me get out a little sheet of paper just to make this the easiest as we can. All right, so SM. We're going to read this like a book, and we're just going to work our way down to number 62, which is what SM is. All right. In order to get to SM, I'm going to read through or go through level 1s. The s orbital can fit 2, so this is going to be 1s2. Then I'm in 2s. We're going to go all the way through 2s, so that's going to be 2s2. And we're going to keep reading, and we're going to go through 2p. P fits 6, so that is 2p6. After level 2, we go to level 3, 3s2. 3 continues, and we pick up 3p6. After 3p, 4s2, then 3d10, then back to 4, 4p6. After 4p6, 5s2, then 4d10, then back, because we ended our D, so now we're here. This is 5p6, then 6s2. After 6s, we bounce down, 4f, and this is going to be 1, 2, 3, 4, 5, 6. 4f6. After you've done a really long electron configuration, this becomes really helpful for you to do other configurations. So say I wanted you to do cobalt. So cobalt's number 27, and it's in 3D, and it's in spot 1, 2, 3, 4, 5, 6, 7. A cheat that you can do is find 3D in another configuration you did, like we have right here. You can copy everything down up until that point. So we know we're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. We're up to the 3D point. We're in 3D 1, 2, 3, 4, 5, 6, 7. 3D 7. By using ones that you've already done, it's a way to work smarter, not harder, and it works out just the same. It'll give you the same answer that you need. Hopefully this helped you out just a little bit. I'll be able to help those of you who are still struggling in class on Monday, and I hope you have a great weekend.